Alright, this is the last section of this chapter for notes, and we're going to talk about when there's numbers in the regions of the Venn diagram instead of elements of a set. I mean, sometimes we have numbers that are in our Venn diagram, but they're elements of set U or they're elements of set S. These are numbers that are found in parentheses that don't represent the elements in the set. They represent how many elements are in that region of the Venn diagram. So there's many situations where we're only interested in how many elements there are in each region, and we don't need to show all of the elements on the diagram. So instead, we write the number of elements in parentheses. For example, the Venn diagram below shows there are 4 elements in both sets A and B. So there's 4 elements in the intersection and 3 elements that are not in set A or B. Then every element in the universal set, which is our box, belongs in only one region of the Venn diagram. So in total, there are 7 plus 4 plus 6 plus 30 elements in the universal set. Plus 3, sorry. So there's 20 elements total in the universal set. So here we have a Venn diagram, and again, the 3 in parentheses means there's 3 elements in the intersection set of P and Q. So how many elements are there in P? Well, in P, that's our circle right here. We have 7 plus 3, so the number of elements in set P is 10. There's 10 elements that are in P. The number of elements that are in P union Q, if I go down, I'm actually working on C next, but actually let's go ahead and go across. The number of elements that are in the complement of Q, which is not in Q, we're going to not count any of these, so because these are in Q. So we have 7 plus 4, which is 11. There are 11 elements that are in the complement of Q. Then if we go P union Q, that's all the elements that are in both P and Q combined. So here's the elements in P, here's the elements that are in Q, and we want to add those together because union means we're going to get the total or put them all together. So we get 7 plus 3 is 10, plus 11 is 21. So the number of elements in P union Q equals 21. The number of elements that are in P but not in Q is what we're going to take is, here's our P, but we do not want the ones that are in Q. These are in Q, so we're going to cross those off. So the number of elements in P but not Q is just our 7. So we have 7 elements in P but not Q. Q but not P, we're going to do the same thing. We're going to take Q, but we don't want P, so we're going to cross that out. So we get 11. So there are 11 elements that are in P but not Q. And then neither P nor Q means we want to know how many elements are not in P and not in Q. All of these are in P or Q, so we don't want them. The only ones that are not are those 4. Venn diagrams allow us to easily visualize identities such as the number of elements in A intersects not B, or the complement of B. And we can write that as the number of elements in A minus the number of elements in the intersection of A and B. So that would be right here. We want all of A, but we want to subtract the intersection. So this is where those would be. And then the same thing with the other one, number of elements that are in the complement of A intersects B. We would take the number of items in B and subtract the intersection. So for this second part, we would end up with this instead. This would be A prime intersects B, or the complement of A intersects B would be this section right here. So if we're given that we have a universal set, and the number of elements in the universal set is 30. Remember, this is number of elements. The number of elements in set A is 14. The number of elements in set B is 17. And the number of elements in the intersection of A and B is 6. We can draw a picture where we have our universal set, and then we have A and B do intersect, so I want to make sure that I draw my Venn diagram where I have an intersection. And that's where I'm going to start. I'm going to start with my intersection, and it says I have 6 elements in my intersection. Then it also says I have 14 elements in A. Well, if I look, this whole circle is A, and I've already accounted for 6 of those elements. So to find the number of elements in set A, I'm going to take my 14 that I should have, subtract the 6 that I already put there in the intersection, and I get 8. So there should be 8 elements that are just in set A and not in the intersection. And then add those together and we get our 14. And we're going to do the B's the same way. The number of elements in B is going to be 17 minus the 6 that we already put there. So we get 11 elements in set B. Now if we add these together, 8 plus 6 is 14, plus 11 is 25. So far we've accounted for 25 elements, but we actually have 30 in our universal set, so that must mean that there's 5 that are not in our universal set, or that are not in A or B that are in our universal set. So now we can start answering the questions. The number of elements in the union of A and B would be everything that falls in these circles. So we've already calculated that down here and determined that that answer is 25. 8 plus 6 plus 11 is 25. So there are 25. And then the number of elements in A but not B would be, we take A, these are in B, so we don't want to count those, so what we're left with are the 8 that were in A and not in B. Okay, so now we're going to get into just some problem solving. We're going to work through about 3 problems together, and then these notes are finished. So we have a squash club that has 27 members. 19 have black hair, 14 have brown eyes, and 11 have both black hair and brown eyes. So we want to place this information in a Venn diagram. So we're going to have our universal set, and it's going to have 27 members in it. And then we've got people with black hair and people with brown eyes. So that's what our Venn diagram is going to look like. And then now I need to figure out where all this information goes. So again, I want to start with my intersection. So here it tells me 11 have both black hair and brown eyes. So those 11 must go in the intersection in the middle. Then it tells me that 19 have black hair. So here's my black hair circle. So I already have 11 of them in that circle. So 19 minus 11 gives me 8 more that need to go in black hair. And then I do the same thing for 14 have brown eyes. I've already got the 11 in there. So 14 minus 11 gives me 3 more that need to go over here. So we end up with 8, 11, and 3. And then now when I add those together, I get 22. And we should have 27 members total. So 27 minus 22 would give me 5. So there's 5 that have neither black hair nor brown eyes. So then find the number of members with black hair or brown eyes. So we're looking for either or. Doesn't mean they have to have both. Well, that means we're looking for the union. So we're looking for basically the union of black hair and brown eyes. So if we look at the union, we're going to add everything up that are in all the circles. So we get 8 plus 11 plus 3, which we've already said is 22. So there are 22 elements in the set of black hair or brown eyes. And then we have part 2 says black hair but not brown eyes. So here's our black hair. We don't want brown eyes, so we're going to cross off those 11, and we end up with 8 in the black hair but not brown eyes section. Okay, next problem is there's a platform diving squad of 25, and it has 18 members who dive from 10 meters and 17 who dive from 5 meters. So we want to know how many dive from both platforms. So if we wanted to build a Venn diagram, we have our diving squad, and then we're going to have those that dive from 10 meters and those that dive from 17 meters. So I'm going to let the 10 meters equal L because it's lower, and the 17 meter, or actually backwards. The 5 is going to be our L, and the 10 is going to be our H. H for the higher 10 meters, L for the lower 5 meters. So we get our higher goes here, and lower goes here. Okay, so outside of the H and the L, out here in this area is going to be 0, because if they're on the diving squad, they have to dive from one or the other. There's no way that they cannot dive at all. So then what I'm going to do is I'm going to label this A. I'm going to label this B, and notice I'm putting it in parentheses because I want it to represent how many items are there. So I know that A plus B has to equal 18 because 18 dive from 10 meters, and that's the H is our 10 meters. And then B plus C is going to be how many dive from 5 meters, and that's 17. So we have A plus B equals 18, and B plus C equals 17. So basically we have a system of equations that we can solve, do something with somehow. So if I were to multiply everything through here by a -1, let's multiply everything here by a -1, then I end up with my top one stays A plus B equals 18. And the bottom one is going to turn into -B minus C equals -17. And if I add those together, then I get that A minus C is equal to 1. So then I can solve and say A is equal to C plus 1. And I can continue to solve it going this way, or until I get down to an A equals. I can plug A in up here and then continue to work it out until I come up with a system. So that's mathematically how you would do it. And I will go completely through that entire process with you at a later time if you really want me to. But there's a really quick and easy shortcut. I just wanted y'all to understand why this math works. And the shortcut is I'm going to add up the 18 and the 17. And what I get when I do that is 35. So I only have 25 people, and if I add these together, I get 35. So that means that I have 10 too many people. And I account for those 10 too many people by putting those in the center of my Venn diagram, saying that B is going to equal 10, because that's the only way that I can make these numbers work to add up to 25 is if these extra 10 are in both. So I'm accounting for them twice. So then if I take and I put a 10 here in the center, and I say, okay, well, we have 10 in the center, then in H I have 18. So if I'm already accounting for 10 in the intersection, then I must have 8 that are out here in just on the 10 meter board or platform. And then if I do the same thing for my 17, then I end up with 17 minus the 10 in the middle, and I get 7 over here on just the low dive. Okay, so a city has a 3 football teams in the league. team A, B, and C. So I'm assuming that I'm going to have a Venn diagram with 3 circles. So I have 1 circle, 2 circles, and 3 circles. And I'm going to have team A, team B, and team C. And then here's my universal set. So it says, in the last season, 20% of the team's population saw team A play. 24% saw team B play. And 28% saw team C play. Of these, 4% saw both A and B. 5% saw both A and C, and 6% saw both B and C. 1% saw all 3 teams play. So using a Venn diagram, find the percentage of the city's population which saw, and so now we need to figure it out. So we're leaving them as percentages, and it says that 1% saw all 3 teams play. So this is where our all 3 teams go. So we're going to put a 1 here for the 1% that saw all 3 teams play. Then it says 6% saw both B and C. So B and C is right here. So we know that B and C is this section right here. That's where B and C intersect, and a total of 6% saw B and C, and we've already accounted for the 1% in the middle, so that must mean that 5% goes here. Then 5% saw both A and C, and here's our A and C area, and we've already accounted for the 1%, so what's left is 4%. And then 4% saw A and B. So again, here's our section for A and B. We've already accounted for the 1, so that must mean 3 goes here. And then 28% saw team C. So team C, we already have 4 plus 1 plus 5. So that's 10. And we got 28%, so 28 minus 10 gives us 18 to go here. And then 24% saw team B, so we've already got 5 plus 3 plus 1, which is 9, and 24% saw them, so 24 minus 9 is 15. And then 20% of the city's population saw team A, and we have 3 plus 4 plus 1, which is 8. 20% minus 8 gives us 12% that goes here. So we figured out our percentages for each section. Remember, again, we're starting with our smallest section, our biggest intersection. So if it's 3 sets, then it's going to be where all 3 sets intersect. If it's 2 sets, it's going to be where both sets intersect. That's where we start. So then, using a Venn diagram, find the percentage of the city's population which saw only team A play. So if we look at team A, we've got just the 12 that's in team A only. So that's 12%. And then the next question says saw team A or team B, but not team C. So we look at everything that's in A, B, and C, but we're going to take out the part that's in C. So we end up with 15 plus 12 plus 3, which is 30. So you get 30% that saw team A or B, but not team C. And then the last one is did not see any of the teams play. So if we add up the total and we look outside, it says that there are 42 teams that did not play at all, so that answer is 42.